Okay, hey everyone. We actually had a similar issue pulling glulam out of a container, but actually in China. We're doing a couple of projects in China right now, and when they were dragging these sleds of the glulam out, also from Europe, they forgot to support the other end, and the container was about 4 or 5 feet off the ground, and of course the whole load at the other end came down with a crash. All sorts of fun unloading containers of glulam. So yeah, my name is Lucas Epp. I'm the head of the engineering department at StructureCraft Builders in Vancouver, Canada. We're a company founded by my father actually about 20 years ago with a focus on creating architectural timber, high-end timber structures. That was kind of our initial mission statement. And the kind of story of the founding of our company was that my dad, who's a structural engineer, he was working on a project in Vancouver, actually the aquarium in downtown Vancouver, and he had been designing this beautiful stainless steel truss and parallam truss structure for about 6 months with an architect. And then when they went out to bid, no general contractor wanted to build the structure. They all said, no, it's too risky and it's going to cost too much. And so he said, well, I'm going to make a company and I'm going to build it because I put so much time into thinking about how this structure could actually be built. And so that's kind of the history of our company is using structural engineering thinking. I'm a structural engineer as well, to influence manufacturing and construction and building buildings. And so we're now into, yeah, we're almost going for 20 years now, and we've been involved in a lot of very high-end structures. By the way, can everybody hear me, or do I need to pick up a mic? All good? Okay. We're doing a lot of high-end structures over the past 20 years across the US and Canada, including long-span roofs, free-form structures, heavy timber, and big glulam trusses, etc. But about 5, 6, maybe actually almost 8 years ago now, we started getting into mass timber. And actually that was before any CLT manufacturers came on board in North America. We started making this nail laminated product. And one of the original reasons we were interested in this product is because you can do really cool things with the product from a geometrical perspective. This is a project that's a free-form roof structure and takes each of the boards of the nail laminated timber panel and kind of rotates them and indexes them one next to each other to create this kind of ruled free-form surface. And so a lot of possibilities architecturally. But of course, there's not a lot of volume in doing these high-end type structures. And so we decided to start focusing on mass timber as kind of so our company kind of now has 2 arms. We still do very high-end structures, but we also focus on mass timber buildings. And this is a project we completed a couple of years ago now, almost, in Minneapolis, which is about 220,000 square feet of mass timber. And I think I talked about this last year, but it's looking at using these nail laminated timber panels as the floor decks and then glulam beams and columns for the primary structure. And a very efficient system. Heinz is the developer, and they delivered this particular structure very cost effectively. And with that project, we saw the potential to really create a new paradigm in construction here in North America. And I think all of you have drunk the Kool-Aid, and you all know what I'm talking about and what's possible. So I won't go too much into that, but suffice it to say that doing this project for our company gave us the confidence to actually put in money into installing a manufacturing facility, and I'll talk a little bit about that later. So our company, pardon me, we are engineers, we are project managers, we are 3D modelers and designers and computational designers, we are fabricators and carpenters, and we are site guys and experienced site superintendents. So we have a vertically integrated structure in our company. And we don't always bring all of those facets to every project, but we have the ability to do so if our clients are interested in that. And so that kind of vertical integration allows us to provide value to our clients in terms of, from a cost perspective, optimizing, providing value engineering, looking at efficient ways of doing things. In the steel world, everyone knows how to connect a steel beam and a steel column. It's a shear tab with a few bolts. In the timber world, connecting a beam to a column, there's probably 40 different options. And some standard, some non-standard, some more and less cost-effective. Some give more or less tolerance to crews who are installing these on site. And so it's a little bit of an unknown world for all of us designers. And so in our company, because we have that kind of real-time feedback from both the manufacturing side and the installation side, it allows us to help choose connection strategies and framing strategies that create an efficient structure. So yeah, we're able to obviously, control production and shipping to site and staging. And when you're dealing with these big structures, particularly when they're in high density urban areas, you need to plan every aspect of the structure. So, the red, yellow, green that you see here, those are actually different levels on a truck. So you know exactly where each beam or each column is going to be on a truck as it comes to site. And it's that level of planning that you need to put into, especially when you get to larger buildings. And also, historically, we were actually not a manufacturer. So we now are manufacturing this product called Dowel Laminated Timber. But traditionally, we actually bought all of our products, and we still do buy most of our products actually externally. And so we have experience working with most of the Canadian and American and European, some of the European suppliers to source material and to understand who is the right fit for the right project. And we've had the fortune to work with probably every mass timber product there is. I think the only one we haven't worked with yet is the new mass plywood panel, which I'm excited to work with sometime soon. So today I wanted to talk a little bit though about how I see the mass timber procurement moving and transitioning. Myself, I spent about 5 years working in London in the UK from about 2008 is when I moved there. And I was fortunate to kind of see the rise of the timber revolution in London and in the UK. And I saw how incredibly fast that took off. And there's now hundreds, if not over 1,000 CLT buildings in the UK. And it's grown exponentially. And that, seeing that really made me realize that there's no reason that couldn't take off here in North America. The distances are bigger, and the cost point may be lower, but the system approach really has a lot of benefits. And so this is a graph I stole from a website, Timber Online. You can have a look. There's a lot of interesting articles from capacity standpoint, but this is one individual's forecast of the CLT production capacity in Europe, looking from 2008 to 2020. And so in the last 10 years, you've effectively seen a 10-fold increase in CLT production in Europe. And that's incredible. It's shocking, actually. So it's, and especially shocking is the rapid uptake in the last 3-4 years. Obviously, the global recession, I think, had a downwards pressure on the production for some of that time, but we're now really starting to see it take off. And there's a lot of suppliers with a huge capacity. And this is looking at CLT capacity. And don't take this as gospel here. This is just me looking at some numbers on a website and putting them into a table. So it may or may not be completely accurate, but the most important thing is it gives you a feeling that there's a lot of suppliers with a huge capacity. And we heard from Katerra their plans for this 130,000 cubic meter plant, which is huge, but it's still not a huge amount compared to the capacity that there is in Europe. And so this robust manufacturing capacity we see in Europe really gives us hope that that's going to generate here. And we're seeing a lot of different suppliers come online here in North America as well with significant capacity. Similarly for glulam, and actually much more so for glulam, there's a huge capacity for manufacturing glulam. And these numbers I think include not just custom project glulam, but also some straight glulam for things like houses and stuff. But still looking at even as a rough order of magnitude, there's a serious amount of capacity for glulam in the next few years, and we're starting to see that in North America. So now looking on the North American side, glulam is typically, from a production standpoint, being quite a manual process. But we're starting to see that change. Some of the suppliers, like Rosborough here in Oregon, have automated production systems, primarily aimed at the residential glulam market. But we're starting to see more and more people invest more money into automating and creating more efficient means of creating glulam here. And this is again one person's estimate, I think, from a little while ago of the capacity in glulam here in North America. And then of course the cost point is important. And right now the glulam price in Europe is cheaper than it is here in North America. And that's partly to do with the lumber species. It's partly to do with the volume of capacity that there is in Europe. And it's partly to do with the lumber prices that are currently we have here in North America, which are significantly higher than they are in Europe. We've seen a large influx of European product actually coming into North America, even just raw lumber, just because of how high the prices are with the expiration of the softwood lumber agreement, et cetera. So there's a movement towards, though, an increase in production and an increase in the quality of production, both glulam and CLT. And on the CLT front, you know, we might be at 200,000 cubic meters a year right now for actual suppliers who are producing here in North America. But with all these players that are coming to the table, International Beams, Katerra, you know, we could see that number in a few years get it much closer to 1 million. And that's, you know, starting to get towards where the Europeans are. So, and the interesting thing on the CLT side is we don't see the same huge spread on costs between Europe and North America that we do on glulam. And there still can be a spread, but it's not as significant as you do for the glulam side of things. So that's glulam and CLT. Nail laminated timber, you know, we did a lot of that as a product, and it's a bit of a flawed product because it's got nails everywhere in it. You can't cut it easily with a saw. You can't CNC it. And we did it because there was a lot of demand for a cheaper product. And I think it still does have potential here in North America over the next little while, particularly due to the transport costs we have here and how far away things can be. So, you know, for example, there's a project happening at Georgia Tech, I know right now, where they were able to fabricate the nail laminated timber locally for way cheaper than anybody could have ever shipped that product from where the current manufacturers are. And I helped write this nail laminated timber design guide to try to get that out to the market as a potential design option for people to really start, you know, kind of a grassroots thing in their hometown to be able to bring mass timber to the table. Now GLT, as we call it, for glulam laid on the flat and uses a floor deck, that has a lot of opportunities, but here in North America, the production is typically limited to around 4 feet. And so you don't see as wide panels as you would with CLT or nail laminated or dowel laminated timber. And the cost point tends to be higher. So it's not really taken off here in North America as a floor decking product. LVL similarly has not taken off hugely. Nor has LSL due to, you know, constraints around how thick the panel is and aesthetics, but it has been used a few times. Parallel strand lumber, an invention by Weyerhaeuser back in the 80s or 90s, an incredibly, probably one of the most dense and strong mass timber products, and you can actually get it in reasonable thicknesses, but it's also very expensive, uses Douglas fir, and so probably not a volume product for the mass timber industry. The mass plywood panel, obviously just coming online, we don't know a huge amount about it yet, but very strong, very stiff panel, and an interesting production methodology. And then we've just launched this product called Dowel Laminated Timber, which uses hardwood dowels to connect these parallel boards together to create a 100% wood product without glue and nails. But again, a new product just coming online. So there's a big kind of a lot of innovation happening around mass timber products here in North America right now. So Dowel Laminated Timber, why did we choose to invest in a new product? I mentioned about nail laminated timber is really not a sustainable product type. So with DLT, you have a product which is 100% wood. It's a fast manufacturing process. You don't have to wait for glue to dry when you're making the product. It's easily CNC'd, and of course, it's got this great story from a carbon footprint perspective. But it's not always the right product for the right job for all jobs. And we still use CLT and glulam and all the other products as a company. So sometimes it makes sense for example, for one-way spans for floors and roofs, it's very efficient structurally. But for a shear wall, it's probably, especially in a bigger building, it's probably not the right choice. So there's always pros and cons to each of these materials. But one of the interesting things with dowel laminated timber is because each of these boards goes through a profile molder, we're able to do all sorts of things with the underside of the panel. So it gives you a little bit more surface finish flexibility than you might have with, say, CLT, where you're fairly limited to kind of a flat, plain surface. And sometimes that's what people want. But other times you want to do something a little bit more interesting. And so there's more possibilities with what you can do. And this is the idea of, from Europe, actually, I think it was invented in Switzerland at Shop Holzbau. The Bresta product, they came up with this concept of putting wood fiber in between these boards and changing the aperture of the gap between the boards to actually allow acoustic absorption. So now you have a product that's acting as your structural panel, but it's also absorbing sound. So kind of a dual product, and something that we actually used to build our new office building, which is kind of attached to our manufacturing facility. I'll show you later. So the opportunity to look at a lot of different profiles and aesthetics and panel, even species. We can make this with Alaskan yellow cedar or red cedar, or we're not limited in terms of the species, because the structurally this panel actually just works by each board spanning between the supports. And in the NDS, everybody knows what a spruce or a Doug fir board how it can span. So you don't have to go do extensive product testing to develop new species to be able to use for this Dowel Laminated Timber product. And in Europe, there's about, I think there's about 15 or 16 suppliers of Dowel Laminated Timber. So it's not a new product. It just hasn't come over to North America yet in the same way that CLT has. And so we're excited to bring it as a new option to the table to the North American market. And we're also currently doing some research with timber concrete composites, looking at how to create notches in the panels to create composites. Because a lot of the systems that use screws or steel plates, they're not very cost effective. And in Europe, there's been a lot of research done in this type of composite type connection, and so we're researching that right now. So talking a little bit about our new plant, so this is kind of a rendering, and then this is the plant here. So it's a 50,000 square foot facility in Abbotsford, BC, just outside of Vancouver, and represents a significant investment for our company in terms of investing into machinery, as well as kind of keeping our one half of the buildings still dedicated to our custom high-end projects. So it's a manufacturing facility, but it's also an office building. So we have about 40 people in our office, and this is a little shot inside the manufacturing facility. On the left side, we've got our production line for Dowel Laminated Timber and coating line, and on the right side, we have our custom project line. And this is our dowel laminating machine, actually manufactured in Switzerland, and over a year in research and development for this machine. It's the largest and fastest in the world. And one of the reasons DLT hasn't taken off in Europe to the same extent CLT has is because the manufacturing process was never scaled up. It was always kind of a smaller approach to things. And so this is now a much faster and a much bigger DLT press than any of the European suppliers have. So this can manufacture panels up to 60 feet long and up to 8 to 12 feet wide. And so in our production line, we've got a structural finger joiner and a profile molder, which puts in all these profiles into the bottoms of the boards, and then the dowel laminating press, which joins them together into a panel. But I wanted to talk briefly about our actual manufacturing facility, because we use that as an opportunity to investigate cost-effective industrial buildings. Because I don't know about you guys, but in Vancouver, all the industrial buildings are tilt-up, and you go into the tilt-up jungle, and it's not very pretty, and it's not a great work environment in our feeling, particularly for our company. Obviously, we had to build with wood. And so we put our thoughts to how can we create a cost-effective system out of wood that would actually compete with tilt-up. And so we created a modular system for both our roof and floor panels. And this isn't mass timber per se, although it uses glulam and LSL and various other mass timber products, but it's a panelized system more. And so these roof panels are 12 feet wide by 60 feet long, and the wall panels are 12 feet wide by about 35 feet tall. And so this kind of modular systemized approach allowed us to prefabricate the, let me just play this video here, to prefabricate the structure. And it actually allowed us to put it up right in the middle of the Canadian winter. And so this kind of tilt-up panel, pre-insulated panel approach to creating our walls proved to be very effective, and we were able to install this building from the foundations to the roof, so all 4 walls, the roof, and the supporting columns down the middle. We were able to install this building in 5 days. So an incredibly quick installation procedure, and of course our guys had a vested interest in hitting that date, but and they worked their butts off, I can tell you that. But we manage it, and it's a tribute to the idea of prefabrication and what can really be achieved. So you know, a 50,000 square foot industrial building, roofed, you know, well, not roofed, but at least topped out in a week, and then this is our office building here on the outside of the building. And this is just some shots of our guys installing. These are actually nail laminated timber. So our office building is made with nail laminated timber because we didn't have our DLT press yet. But these are NLT walls, shear walls. So you got plywood on the back side of those, and that's acting as the shear stability for the building. That's kind of in a stair area. And this is just some photos of landing these walls and then flying the floor panels into place. And these floor panels actually have that acoustic profile that I was showing earlier, and they have the wood fiber in there too, and it actually does work really well. We've now been in our office for about 6 months now, and yeah, it works really nicely. You can kind of see the aperture here in between the boards to absorb the sound. So now I just want to talk a little bit about some projects that are using Dowel Laminated Timber. So the first one we did in the U.S. was in Houston with Lake Plato Architects. It's the new Museum of Fine Arts downtown Houston, and it's a very simple structure from our perspective. It's just these series of four or six roofs, which create the kind of this atrium space for some of these art galleries. But it was a great experience because we were able to get DLT accepted by the building authorities as kind of a direct equivalent to nail laminated timber, and it was our first project to actually put through on our DLT press and our manufacturing line. And so these are just some photos of these panels being landed into place on site, and the project's not finished yet, but it's come together nicely, and it's going to be a good-looking product. It actually uses, you can't quite see here, but it uses some pine beetle kill wood to kind of give the blue stain look. And then we've also completed a few projects near our facility in Vancouver. There's a recreation center with DLT panels on top of glulam, and also the new airport up in Smithers, BC, way up north. Our guys installed this right in the cold of winter. It was brutally cold, but some beautiful views of the mountains there, and we got some cool shots of flying our DLT panels into place against the mountains. So yeah, we've done about, let's see, 4 or 5 projects now with the DLT, and the next one that we have on the go is in Des Moines, Iowa. It's a 4 or 5 story office building, which is going to be the lateral stability system is actually precast walls. So it's actually the first time we had kind of combined mass timber with precast, looking at the stability system. So that's going to be a cool project. Oh, it's got sound. This is just showing some renderings of the building. If I can turn the sound off here. Sorry for the cheesy music. But yeah, it's definitely one of the first mass timber buildings in that area in the Midwest. So everybody there is super excited about what this building is going to mean, and hopefully what it's going to do to the mass timber movement there. And interestingly, it's going to have exteriorly exposed wood, so that's a unique challenge on this particular project. This is kind of a 3D model of the building. So it's a very simple building, but again, just looking at simple, repetitive, and developing a volume for mass timber. That's really one of our focuses right now, on making it cost effective so it actually takes off. There's another project we're working on in Texas, another office building, and with Lake Plato actually as well. And interestingly, on this project, we're looking at supporting a brick facade off of our panels, and that's a unique challenge. In Europe, often when they do brick veneer facades, it's actually supported off of CLT walls. So they've got full CLT punched walls for the windows, and then the brick veneer goes on the outside. And here, of course, in North America, that doesn't stack up cost-wise. And it's, wood and then brick is, so we're coming up with some innovative ways to actually support the brick and make that achievable by cantilevering these floor panels off the sides of the building. And then another project which is currently on the go is in Atlanta is the T3 project we're hoping to be involved in. And the reason I wanted to show this project is it's using exterior brace frames. So from a lateral stability system, the first T3 we did in Minneapolis, that used a concrete core. And this building is using steel braces, and I feel is going to be a very efficient approach to achieving the lateral stability. And of course, it all depends if you're on the West Coast versus the East Coast and what your seismic region is as to what's an efficient system. And then just to finish things off, I wanted to talk about the framework project. I think I've talked about this for at least 2 mass timber conferences now, and a lot of people asking me what's happening with this project. And it seems to be moving forward now, finally. And so we're looking to hopefully break ground in the next few months here. So that's exciting news, and it's going to really be a tribute to mass timber here in the Pacific Northwest. 12 stories using these post-tensioned rocking wall cores. How many of you know what a post-tension rocking wall is? A decent number. So it's an incredibly unique seismic system. If you went down to Peavy Hall yesterday or on Tuesday, I guess, for the tours, you would have seen that, and I described that to some of you, how these rocking walls work, and they dissipate energy in a seismic event. So it's a really unique system, creating a low damage design building, which is self-centering. And so we've had a great experience working with Lever Architecture, KPFF, Consulting Engineers, Walsh Construction, and a whole project team has put an incredible amount of energy into this project. Unfortunately, due to funding issues, it got put on hold for a little while, but it looks like it's coming back now. And it's going to be it's an incredibly complex building, but it's going to be really a world first in a seismic zone for this height and for the level of performance that's going to be achieved from a seismic perspective. Also from a fire perspective, a lot of the beams, columns, and floor panels, and even some of the wall panels are going to be exposed. And because this is 12 stories, it needs to meet 2-hour ratings. And so because this project won the USDA Tallwood grant, we were able to do a lot of testing with a lot of different universities and labs, OSU, PSU, and then also down in Texas for some of the fire testing and acoustic testing. And we were able to demonstrate the 2-hour rating of both beam to column connections, also the floor systems. And so it's really a tribute to what's possible with mass timber, and now we just have to get it built. So it looks like it's coming together. So with that, I'll close and ask for any questions.